Hello students, welcome to the lecture series on UPSUC for first WTech first semester. Today we'll be starting the fourth unit. In fourth unit, what we have is pointers and the applications of pointers in various C data types. Also, we will see the advantages and disadvantages with pointers. Let us start the discussion by using some introduction to pointers. The definition of a pointer variable is it is a variable which is capable of storing address of a general variable. That means a general variable can store a value, whereas a pointer variable can store the address of that general variable. So majorly pointers are used for storing addresses of variables. Okay. So that is the basic definition of a pointer. And to work with these pointers, we need to know about two operators, special operators. One is address of operator, and the other one is star operator, which is also named as indirection operator or dereference operator. We can also call it as a pointer operator. Star represents a pointer, that is dereferencing a pointer is done with the star operation. Okay. This address of operator, when it is applied on a variable, it returns the address of a given variable, and this indirection operator or dereference operator returns the value at the address pointed by a pointer variable. That means if you say star x, it returns the value stored at the address containing x that is contained in x. Okay. So dereferencing operator always returns the value pointed by the address stored in a particular pointer variable. So that is the meaning of star operator. You see that these two operators are essential to work with pointers. We're looking at some examples later on. Let us start with how to declare a pointer variable. General variables are declared by using the syntax data type space variable name, whereas pointer variables are declared as data type space the star operator. This is special here. By using this star, we declare that this variable is going to be a pointer variable which can store the address of the data type which is specified over here. Okay. So the pointer variables can store addresses of the specified data type only. They cannot store the addresses of other data types. Okay. Now let us understand this concept with an example. Let us say a variable x is declared using int x. So x is an integer variable, and I'm placing x is equal to 25. That means 25. Value 25 is copied to x. It is assigned to x. So now x contains 25. Assume that the address of the memory location assigned to x is 2000. That means the memory location where x is created is 2000. Now let us declare a pointer variable int star p. Why we require an integer pointer here? Because we want to store the address of an integer variable. To store the address of an integer variable, you require an integer pointer. So int star is mandatory here, followed by any name. This is just a name created over here, variable name, without violating the naming rules of variables. Okay. Now let us assign the address of the general variable x into p. How can we do this? By using ampersand operation. Ampersand x returns the address of x and then copy that value to x. So now p contains address of variable x. What is address of variable x here? It is 2000. Therefore, p contains 2000 as its value, where 2000 is address of x. And this is also a variable anyhow. It also contains some memory location address here. Let us assume that it is 5000. Okay. So you need to understand few things here. P is 2000. Ampersand P is 5000. That means address of P is 5000. X is 25. Ampersand X is 2000. Now, if I perform x plus plus, it means the value in x is incremented by 1. That makes x value to 26. Okay. We can also perform operations on x indirectly by using the pointer pointing to x, because p is pointing to x memory location. We can perform operations on x with the help of this pointer variable. So let us see how to do it. Star p refers to this value, that is x value, the location x. If you say plus plus star p plus plus, the incrementation is done on x itself. Okay. Therefore, the value of x will be now changed to 27. It's already 26 in the previous implementation with the x plus plus. Now it becomes 27. So if you observe this, either you do x plus plus or it is star p plus plus, both statements performing incrementation operation on x only. That means there are two ways to perform operations on variables now: direct operations and indirect operations. Pointers helps us to perform these indirect operations on general variables. Okay, so x plus plus is same as star p plus plus, as we saw in this example. So this is a simple introduction to pointers. With the help of this example, we understood that a general variable is created and a pointer is pointing to the general variable. We can perform operations on general variables directly or indirectly with the help of pointer. Let us have a look at the advantages of pointers. Uh, with the help of pointers, what we can perform is functions, which we are going to learn in 5th unit, are generally return only one value, whereas with the help of pointers, we can return more than one value from a function. Okay, this is the first advantage with pointers. Second advantage with pointers is pointers can be used to access the individual elements of an array indirectly. Either you can use indexes or you can use pointers to access the elements of an array. And memory is allocated dynamically during runtime. That means during execution of the program with the help of pointers. And fourth advantage is manipulation of arrays and strings becomes easier with the help of pointers when they are sent to functions as parameters, because we can easily catch the arrays and strings through pointers in function definitions. Fifth advantage with pointers is they can be used to create complex data structures such as stacks, queues, and linked lists, and so on. You will learn all these advanced topics in further semesters. Okay. And the sixth advantage with pointers is pointers are used to access the values of variables indirectly. Actually, this is the basic purpose of using pointers. Whenever you want to access the data indirectly, then you can go for pointers. Okay. Anyhow, uh, there are many advantages with pointers, but also disadvantages are there. Pointers makes your program difficult to understand. That means the program that we develop using pointers will miss the readability. That is the disadvantage. With pointers. Now, let us understand how pointers can be used with one-dimensional arrays. When an array is created, specifically a one-dimensional array is created, the array name, let us say here it is A, contains the base address of the array. That means A stores the base address 2000 in this example uh, in its memory location. So the name of the array stores only the base address, not the entire array. And by using this base address, we can move to the next location with the help of some pointer arithmetic. Okay, that means if you say a plus 1, it goes to the second memory location by using the formula 2000 plus 1 into size of integer. Okay, if you want to go to the second memory location using the index a of 2, then it calculates the base address plus 2 into, that means number of locations to move the index into the size of integer. That gives 2004 as the location's address, and so on. If you want to access a of 5, it will be calculated as the base address plus 5 into size of integer. That means 2000 plus 5 into 2, assuming that integer size is 2 bytes. It gives 2010 as the address of this memory location, and so on. So internally, pointers are used to calculate the address of a particular memory location when they are referenced using indexes. Okay. And also, when we send a one-dimensional array to functions as a parameter, the actual parameter, then the former parameter can be a simple pointer, a single pointer to catch these arrays, one-dimensional arrays. So it will be helpful in operating with arrays during the function call. So we'll learn this topic in the 5th unit when we discuss about the functions and arrays. Okay. So as of now, just understand that name of the array contains the base address of the corresponding array, and we move on to the further locations by using some pointer arithmetic. That is the point we need to understand. And the important concept which is required here, the more complex topic, is double pointers. So what is a double pointer? Double pointer is a pointer variable which stores the address of another pointer variable. A single pointer is a variable which points to address of a general variable, whereas a double pointer is a pointer variable which stores the address of another pointer variable. This is also called as pointer to pointer. Let us understand this with the help of an example. Say I have declared an integer variable x and storing the value 15 into it, x is equal to 15. Now x is created in the memory with value 15, and assume the address of x as 2000. This is just an assumption, and create a pointer variable p1 int star p1. P1 is equal to ampersand x to store the address of x into it. That means P1 stores the address of x. What is address of x here? It is 2000, so it is stored into P1, right? And then I'm creating a double pointer. See the syntax of creating a double pointer. If you want to create a single pointer variable, you require one star operator here. If you want to create a double pointer, you require two star operators over here. So int star star P2. This declares P2 as a double pointer, which is now capable of storing the address of a single pointer variable. That means address of P1, now ampersand P1, it can be stored into P2. So what is address of P1 in our example? Let us say it is 3000. Now 3000 is stored into P2. Okay. Now P2 can also have some address. Let us say it is 4000. So what is P2? P2 is 3000. Address of P2, if it is written over here 4000, we can assume it like 4000 here. What is P1? P1 is 2000. What is address of P1? It is 3000. And what is X? It is 15. What is address of X? It is 2000. Okay. You need to be sure about these X and ampersand X, P1 and ampersand P1, P2 and ampersand P2. Now, P2 is a double pointer. What we can do with this is, by using star P1, you can access 15, and by using star star P2 also, you can access X now. Okay, so there are two ways, actually three ways to access this value 15. By using a direct access with the help of X variable X, that is X plus plus can perform an increment to 15 over here, or as we saw in earlier example, star P1 plus plus also can increment the value of X. Now there is one more way to access the value of X using star star P2 plus plus. Star star P2 plus plus can also increment the value of X. Okay. Now X plus plus or star P1 plus plus or star star P2 plus plus are all going to be same to perform an increment operation on X. Okay, so you can increase the number of dereferencing operators here based on your requirement. it can be extended to any level. Okay. These double pointers are useful while working with two-dimensional arrays. We will see that how to work with two-dimensional arrays and all in fifth unit while discussing about the functions. Okay. As of now, just understand the definition of double pointers, which will be used in fifth unit. The application we will see it in fifth unit. This is an important topic for your examination point of view. Pointer arithmetic or operations on pointers. Uh, there are several operations, valid operations that are allowed on pointers. Uh, these are these six are the only valid operations that can be performed on pointers. You need to remember all these operations. We can do an increment to a pointer variable, and decrement to a pointer variable, adding an integer to a pointer variable, subtracting an integer from a pointer variable. We can perform subtraction of a pointer variable from another pointer variable, and we can also compare any given two pointers. These are the six operations that we can perform on pointers. So let us understand these operations one by one now. The first operation is increment a pointer. When a pointer is incremented, the result of pointer variable depends on the data type that is pointed by the variable. That means if it is an integer, it will be incremented by the size of integer. If it is a float, then it will be incremented by the size of float, and so on. So it depends on the size of the corresponding data type which is declared. So the formula is P is equals to P plus size of the data type pointed by P. Therefore, the incrementation operation depends on the size of data type which the pointer is created. Let us understand this concept with an example. Say there is an array int a of 9 is created, and now it is int star p is equals to a. That means a stores base address, as we know. Now p is referring to the same array that is pointing to the base address of the array. Therefore, p and a both are pointing to the one-dimensional array which is created over here. Now, p plus plus means that p is equals to p plus size of int. That means size of, why we are taking size of int here? Because the pointer variable is integer. So p plus size of int, assuming that size of integer is 2, moves p to 2002. That means the pointer moves to the second location, and so on. If you keep on incrementing the pointer, it moves to the next element, and so on. Okay. So this is how incrementation is done on pointers. Okay. Now decrement operation is also similar to the incrementation operation, except that the operation is using a subtraction of operation here. Pointer variable is subtracted by the size of the data type pointed by the pointer variable. So if p is pointing to some address, then you need to subtract the size of data type from that address to get the resultant address after performing decrement operation. We'll continue the same example of which we described in the previous increment operation. So there is an array and the p is pointing to the array. If you perform p minus minus, assuming that p is at that second position 2002, then what happens is p is equals to p minus size of int. So what is p? It is 2000 to the address. P minus 2 makes it as 2002 minus 2. That means 2000. So it goes back. Increment operation takes the pointer variable to the next value, whereas decrement operation takes the pointer variable to the previous location. That means it moves to 2000 in this example. Okay. And adding an integer to a pointer variable is similar to the previous two examples, where it is 1 into size of data type. Now it is n into size of data types based on the number which we want to add into the pointer. Okay. So p plus n means that we're assuming that n is an integer. P plus n means that p is equals to p plus n into size of data type pointed by p. So in case of increment operation or decrement operation, this is 1 into size of data type. Now it is n into data type, except that everything is else is going to be same as the previous two operations. Let us continue with the same example. Again, p is at 2000. Now I want to calculate what is p plus 3. Then it becomes p is equal to p plus 3 into size of integer. Assuming that size of integer is 2, 3 into 2 is 6. Therefore, base address p is 2000. 2000 plus 6 becomes 2006. Therefore, pointer p will be moved to this location, 2006, after performing p plus 3 operation. Okay. Similarly, we can perform subtraction of an integer from a pointer variable, which is done using this formula. P is equals to p minus n into size of data type pointed by p. In previous example, it is p plus when we are adding an integer to a pointer variable. Now it is p minus n into size of data type pointed by p. Okay. So assume that pointer p is at a plus 5. That means from base point it is at 2020. Okay. At the address 2020. Now p is pointing at this location. If I perform p is equal to p minus 3, then the value of p becomes p minus 3 into size of float, because the data type we declared is float. Size of float is 4 bytes, therefore 3 into 4 it is 12. P minus 12 it becomes. Then 2020 minus 12 is 2008. Therefore, P moves to this location after performing P minus 3. Okay. Subtraction of pointers from another pointer can also be a valid operation on pointers. Assume that there are two pointers P1 and P2. P1 minus P2 will return the number of elements between P1 and P2. Okay. So let us understand this with an example. Assume that P1 is pointing at this location 2000 and P2 is pointing at this location 2020. If you perform P2 minus P1 or P1 minus P2, both will return the difference. That means the number of elements between these two pointers, that is 5. So that's all for today. Now, what we discussed today is we introduced to a difficult topic in C language, that is pointers. It is different from the regular general variables, as general variables can store only values, whereas pointer variables can store address of variables. And how these pointers can be used with one-dimensional arrays and two-dimensional arrays. And also we discussed about what are the possible advantages with pointers. And then we saw a very important question, pointer arithmetic. That means the operations, the valid operations that can be performed on pointers. Except these operations that we discussed here, no other operation is allowed on pointers. That means if you want to perform addition of two pointers, it's an invalid operation. And of course, we discussed, we actually listed 6 over here. The sixth one is comparing two pointers. It works similar to comparing any two integers. Like, for example, if the addresses are same, then it returns 0. Otherwise, it returns true. Otherwise, it returns false. So pointer variables can also use that comparison operator just like a general variable. Okay, that's why I will not discuss it. And other than these 6 operations, no other operation can be performed on pointer operators. So pointers. Okay. So that's all for today. Thank you all for your patient listening. When we come back in the next session, we'll be discussing about continuation of these pointers. We discuss about what is runtime memory allocation, what are the disadvantages of static memory allocation, and how to perform this runtime memory allocation with the help of predefined functions available in C language. So we'll see that in our next class. Thank you all once again.